All right, guys, section 6.4 is all about rational exponents. So our exponents are going to be fractions now. Yay! But the point of this section is we can learn to rewrite radicals in exponential form, so as an exponent, or you can take rational exponents and you can flip it into a radical. They work back and forth together. So first thing we need to know is how they kind of work together. So the nth root of x is x to the 1 over n. So in other words, when you're looking at this, I like crazy ways to remember things, right? This is called the index. Well, what's another name for it? The root number. Yeah, you're right. You look very shocked by that. Like we would say like the cubed root, the square root. We call it a root. Where do roots grow? Underground. So the root number grows underground. It is the denominator when you flip those. Okay, where did the 1 come from? What's the exponent on that x? A 1. Yeah, the top number is an exponent, and the bottom number is your root or your index. But it always helps me to remember that because, you know, if you flip-flop those, you get a very different answer. So roots grow underground, so the root number or the index number is the one underneath. Okay, roots grow underground. So radical expressions can be written in exponential form. Which is exactly what that example did, right? It took a radical expression, the nth root of x, and it rewrote it as something with an exponent. So they can go back and forth. So then rational exponents can be written in radical form. So when you think of the word rational, it just means a fraction for an exponent. Okay, so today's focus is kind of working back and forth between those two. Okay. So if I have the 5th root of 9, how would you rewrite that? Okay, it'd be 9 to the 1/5. There you go. Remember, roots grow underground, so that's the underneath number. Okay, the cubed root of 10 would be 10 to the 1/3, right? Because there's no exponents, we assume it's a 1. Radical 7? 7 to the 1/2, right? Square root of 7. The 8th root of 5x. Say that again. Okay, you said 5 to the 1/8. Yeah, like this? Wrong.
5 to the 1/8 x.
You could do 5 to the 1/8 and then x to the 1/8, or there it is, 5x in parentheses to the 1/8. Because aren't they both underneath that radical? Both of them are taking the 8th root of them. Okay, I'm lazy. I'd probably go with option 2. I'd write 5x in parentheses and put 1/8, but I'm lazy. So either one's fine though. But you need something that shows that the 1/8 is actually on both of them, because they're both underneath there. All right, so let me give you guys a minute or so to do these 5. All right. Robert, what'd you get for number 1? Good. 12 to the 1/7. All right, number 2, Marissa? Perfect. Number 3, Jasiri? Over 1/2? Okay. Exponent 1/2. Perfect. All right, it's number 4, Jonathan? Perfect. So he chose the lazy man method and just put parentheses. Or you could have done 6 to the 1/4, m to the 1/4. Either way. Number 5, Olivia. Perfect. Questions so far? Awesome. All right. Okay, can we go the other direction? So 3 to the 1/5 is what? Good. That would be the 5th root of 3. Remember, the roots grow underground. So the denominator, the part under the fraction, that's your root number. All right? 16 to the 1/2, which is? Good. You always want to simplify if you can. Y to the 1/7. Perfect. 7th root of y. 9x in parentheses to the 1/4. Good. 4th root of 9x. And then 5x to the 1/3. Beautiful. That one's just 5 times the cubed root of x. Because what do exponents go to? Whatever it's right next to. So in this case, it only goes to the x. What's the exponent on the 5? It's a 1. So if it's just a 1, that doesn't do anything for me. So if it has a fraction for an exponent, that's when they go up underneath a radical. If there's not a fraction, it does not go underneath. All right, so let me give you a minute and do these 5. All right, so number 6. Corbin. So anyone help him out how that's worded? There you go, the 6th root of 19. Yeah, not only do we need to know how they switch, you really should learn how to say them. Okay, it's always entertaining to hear how people describe things. Number 7, Savannah. Good, cubed root of r. Number 8, Carrie. Which is? 2 radical 2. I know you're like, dang it, I forgot to simplify. Number 9, Ruben. Like that? Good. Right, they were both underneath there, so that square just goes underneath. And number 10, Carson with a C. Is 14 under or out? Out, good. 9th root, okay, good. Be careful on 10, make sure that 14 is not under the radical. Because the 1/9 is only on the k. That 14 is a 1 on it. Okay, so just be careful. All right. So this just kind of breaks it down further. We already just talked about it, so it's not really much different. It's just showing you that if something in here has an exponent, that it's going to be at the top number. Some textbooks would put the exponent like right up next to the radical symbol, which is weird to me, but I just wanted you to see it. If it looks like that, that is an exponent here. I like them underneath. It looks better, but it does show up like that in some textbooks. So if I have the 5th root of 3 squared, how would you write that? It'd be 3 to what power? 2/5. Because where do roots grow? Underground. Bottom. Underground. All right, so the next one, the square root of 6 to the 5th would be 6 to the 5/2, because that index number is a 2. Roots grow underground. Yeah, on bottom. The 8th root of n to the 11th would be n to the 11/8. And the 6th root of 2xy in parentheses to the 5th. 2xy in parentheses to the 5/6. Perfect. See, isn't this fun today? Danny? Yes. Yes. All right, your turn. Take a minute. Try these 4. All right, so number 11. Let's go Carson with a K. Perfect. Number 12, Brittany. Very good. Number 13, the square root of 25 to the third.
Oh, each with a 5 is like the square root of 5. Right? Oh, but
Oh, no, hold on. You're going, oh, you opened up a very interesting conversation.
oh, yeah, we should be 3.
So you could do that. Hold on. What she was just saying, just because I want to go with this. She said 25 is 5 squared. But if that's to the third, that's actually 5 to the what? 6? Oop. And if I'm doing the square root of 5 to the 6, it's 5 to the third, which is 125. It's 125. Yeah. Now, the original question, if you were just rewriting it, it would be 25 to the 3/2. But I mean, you should simplify. But I mean, that's how you would switch it. Could you also have figured out what 25 to the third actually was?
Yeah.
And then see if it had a pretty square root? It does. It'll be 125. Yeah. But no, I like your method. I like that. 14, Caleb. Perfect. Isn't this fun? Isn't this easy? How about that? Is that a better question? Okay. All right, can we go the other way? All right, so first one, 5 to the 2/3 would be, good, the cubed root of 5 squared, which is the cubed root of 25. Yeah, we want to simplify as much as we can. We know what 5 squared is. All right, the next one would be what root? 10th root of c to the 13th. Can I simplify that? How many groups of 10 can I take out? How many would be left over? Good, so it'd be c times the 10th root of c to the third. We always want to make sure we simplify. Next one. What root? Square root of, okay, so 8 to the 7th and h to the 7th, or you could put them in parentheses. I'm just thinking along of simplifying here. I can break that down. So how many groups of 2 can I take from my 8? 3, so 8 to the third. How many 8s would be left? 1 8 left. Groups of 2 from the h's? Same, so it'd be 3. And there'd be 1 h left. Well, this problem got fun. What's 8 to the third? 512. So I have 512h cubed times the square root of 8h. Wait a minute. What's the square root of 8? 2 radical 2. So what do I do with the 2 out here? Multiply that. So that'd be 1024 h to the third times the cubed root of 2h. That one's fun. That was fun. Could you, from the beginning, figured out what 8 to the 7th was, and then done a factor tree and simplified from there? You could have. It's not pretty. It's huge. You really could have. But if I can kind of pull out groups that way, then it made it a little easier. Yeah. 8 was 2 radical 2, so I just multiplied that by 2. I know that one got a little crazy. They're not always that hard. That was just a really fun one. It was fun. All right, and then the last one. Perfect. That 3 has an exponent of 1, right? That fractional exponent is not on that one. Okay, so that one stays outside. All right, your turn. These 4. All right, so 15. That one's going to be the 8th root of 15 to the 5th. 15 to the 5th is really big. So we'll just leave it. It's really big. 16 becomes the square root of 8 to the 15th. Now, 8 to the 15th, we discovered you get an error on your calculator. It's too big. Your calculator can't hold it. But how many groups of 2 can you take? I have 15 8s. I could take 7 groups out, right? 8 to the 7th. And you'd have 1 left. Okay? And the square root of 8 we know is 2 radical 2. So I'm going to have 2 times whatever 8 to the 7th is. And I don't know if it's too big in your calculator or not. So I say, it's 419. What did you say? 4304. Is that with that being multiplied by 2? Okay. It's a phone number. There you go. What? No, it's not. It was just funny that it started off 419. All right. So, no. 17. What root? Be the 5th root. Oh, I know what you were doing. Just hang tight for a minute. So it's going to be 2 squared a squared b to the 6th and c squared. You could, but I can simplify this. And if it's in parentheses, sometimes we don't notice we can simplify it. What do I have that I can take a group of 5 out? A b. I can take a b out. So b, 5th root of, I would change 2 squared to a 4. A squared, I have 1b left, and c squared. But to answer your question further, Lexi, if it doesn't simplify, yeah, you can just leave it in parentheses. Sometimes it's just easier to see that it will simplify. And 18. Good. 6 is on the outside. Perfect. You're like, please just give me those easy ones, right? Good. Yay. All right, real quick, 19. The directions just say to simplify. So a lot of times when we look at things that have a fraction for an exponent, we're like, I don't know what to do with that. So let's flip it back into radical form. That makes more sense to us. So 49 to the 1/2 really means what?
Yeah.
It is 7, but what does it mean as a radical? It would be the square root of 49, which is 7. Okay, but being able to flip back and forth between the two forms allows us to be able to see how it simplifies better. So number 20, negative 216 to the 1/3. What is it as a radical? Which is? Negative 6. All right, 21, how would that be as a radical? 4th root of x to the 5th. I can take 1x out, and you'd have how many left? Just 1 left. So x times the 4th root of x. I could take 1 group of 4 out, right? There'd be 1 left. Then 8 to the 2/3. 3rd root of 8 squared. What is 8 squared? Is that perfect? Yeah? It's 4. Almost done. Hang with me. We're almost done. I promise. We're almost there. We're almost there. 23. How does that get rewritten? You are having a day today. I should yell at you more often. You're doing great today. That negative, where does it go? It's outside. So that is negative on the outside. And then it is what root? Square root of 4 cubed. What's 4 cubed? 64. Square root of 64 is is 8. So it's negative 8 because the negative was on the outside. 24? How would you rewrite that one? Good. The cubed root of m to the 7th. Can you take any groups of 3? 2. So m squared, and what's left inside? Just 1m. $25? How does that one get rewritten? Good. Notice I still put that negative 32 in parentheses. Why? Yeah, the negative goes with it. So when I square it, what's going to happen to it? It's going to cancel that negative out. What's 32 squared? I really don't know. You have to tell me. 1024? Thank you. Is the 5th root of that perfect? It's not negative anymore. What is it? 4? Well, that's always nice when they're perfect. I don't have to make a giant factor tree. And 26. Negative 27 to the 1/2. Rewrite it into radical first. Negatives on the outside. Good? We know that's not perfect, right? Do we know what it becomes? Good. Negative 3, radical 3. Again, just do a factor tree on your 27. You get a pair of 2s, or a pair of 3s. How we feeling?